Today we're going to be using SOLIDWORKS flow simulation to understand and compare the aerodynamic effects of different bicycle tube shapes. In particular, we're going to be looking at this bicycle seat post. If you don't know, the bicycle seat post connects the bicycle frame to the saddle or seat where the rider will sit. Today we're going to look at the round seat post, which is most common, and compare it to the aerodynamic seat post. I've made a couple different configurations and I've started some flow simulation studies. Let's take a look at the input. General settings, and you can see we're running an external study. The fluid is air and the initial conditions are 20 degrees C and a velocity of 10 meters per second. This is taking place around sea level. Alright. What I want to learn, or what my goals are, I need to understand the drag force these different tube shapes have at this velocity. I've already specified my drag force in the x direction. That's the same direction as the velocity of the air. From drag force, I can calculate drag coefficient. This is an equation goal. Last, I want to figure out the drag power, which is essentially the drag force times the velocity. This is going to give me how many watts it takes to move this part, or to move this tube shape through the air at this speed. I can also take a look at my computational domain, and you'll notice that I have it symmetric about the middle of the part. This is a good option and speeds up the performance of the study. The studies are set up pretty similarly. If I take a look at my global mesh, I've chosen the manual option, and I'm choosing a level 3 refinement for the fluid solid boundary. Once it's meshed, I can begin to review the level of accuracy of the mesh. You can see I have an appropriate number of cells where the fluid will be coming in contact with the post. All that's left is to run the study. I've already ran these studies previously, so we can take a look at the results. I can create a cut plot. I can also show flow trajectories or any other means of post-processing. Let's take a look at the round post. I'll go ahead and load the results and take a look at the same cut plot. Next, I'll create a goal plot. I already have one made. And this will show me the results of my goals that I created previously. What I can do next is compare the results of these two studies. I can take a look at the goal plot, and I can see the aero post requires less power to move through the air at the same velocity. Thanks for joining me today. I hope you enjoy the summer, whether you're cycling or not.